dashboard 3.2 NDFC for VXLAN eVPN multi-site deployment. What is NDFC? Cisco Nexus Dashboard Fabric Controller. That is application inside the Nexus dashboard offers the network management system and the support for traditional and multiple tenant LAN and the SAN fabric on a single window. We can use it to work across all Cisco Nexus and MDS switch families, and we use it to manage large numbers of devices. We're providing ready-to-use control management and automation capabilities, including VXLAN control and automation for Cisco Nexus LAN fabrics. And it supports automatic configuration for multi-tenant automation. It offers integrated storage, virtualization, provisioning, and troubleshooting, and so on. So what is VXLAN? It is an overlay technology for network virtualization. It provides layer 2 extension over a shared layer 3 underlay infrastructure network by using a MAC address in IP UDP. We call it MAC in IP or UDP tunneling encapsulation. Sounds pretty cool, right? The purpose of obtaining a layer 2 extension in the overlay network is to overcome the limitation of the physical server racks and geographical location boundaries to achieve a flexibility for network workload placement within a data center or between different data centers. So initially, there's IETF VXLAN standards. It's RFC 7348 that defines a multicast-based flood and learn VXLAN without a control panel. So it relies on a database flood and learn behavior for remote VXLAN tunnel encapsulated endpoints that we call VTAP peer discovery. And we have a remote and host learning. So we have the overlay broadcast, unicast, and multicast bomb traffic are encapsulated into a multicast VXLAN packet and transported to remote VTAP switches through underlay multicast forwarding. Flooding in such deployment can present a challenge for scalability of the solution. So the requirement is to enable multicast capabilities in the underlay network. Also, it represents a challenge because some organizations do not want to enable multicast in their data center or WAN network. Let's take a look, for example, today's diagram. To overcome, we have a limitation of the floods, we call the floods and learn VXLAN that are defined in the RFC 7348. Organizations can use what calls MP BGP, a multi-protocol BGP. Okay, so and Ethernet virtual private network, we have the eVPN in the overlay. As a control panel for the VXLAN, the IETF defines MP BGP control panel for VXLAN overlays. The MP BGP eVPN control panel provides protocol-based VTAP peer discovery and host reachability information distribution that allows more scalable VXLAN overlay network that's designed suitable for private and public clouds. This MP BGP eVPN control panel that introduces a set of features that reduce or eliminate the traffic flooding in overlay network and enables optimal forwarding for both east, west, and north south traffic. The VXLAN EVPN multi-site feature is a solution to interconnect two or more BGP based. We call it BG, well, the border gateway in here. BG. There's the nodes that interact with the nodes within a site or with the nodes that are external to the site. So, for example, here, a leaf spine data center fabric. It can be a leaf, a spine, or a separate device acting as a gateway to interconnect the sites. We have the border gateway. As you show here is my spine. Is a leaf. It's also a leaf, but we call it border gateway. Okay. Inside is running a control panel, MPBGP, and that's EVPN. We're gonna distribute the VTAPs, peer VTAP discovery, and we have nhost provides the reachability for the nhost. So for this lab, we use Nexus dashboards and the NDFC, and we deploy VXLAN EVPN fabric on my Greenfield. We're gonna import the Greenfield and we're gonna deploy it, and we'll create a brand new and logical interface. So in this lab, VPC interface from my site 1 leaf 1 and site 1 leaf 2 VPC pairs. That will be a VPC. And in the border leaf switch, we have name is the site 1 BGW1. Is to provide external multi-site connectivity towards my core router. And here we have a border leaf. The border leaf is in place to provide external layer 3 connectivity using VRF, we'll call it VRF Lite. When all this provisioned, and we're going to extend the classic Ethernet network to a VXLAN BGP EVPN fabric, including we're going to migrate the first hop gateways where was in the old network. In here, we're going to transition to the new one. In the brownfields here, we're going to show how to migrate an existing VXLAN BGP EVPN fabric to Cisco NDFC. The transition involves like migrating existing network configuration to the NDFC. So typically, I create and manage my fabric using a manual CLI configuration, or I can customize automation scripts. So now I can migrate the fabric through the NDFC. After the migration, the MDFC will manage the fabric underlay and overlay networks. So we'll import and deploy the brownfield into the NDFC, and I remove the bulk creation of network and VRF in this lab. So next I will import and deploy the core fabric here. And I'll configure multi-site. This multi-fabric container created to manage multi-member fabric. So it's a single point of control for definition of the overlay network and the VRF member fabric share. The task we want to do is to import and deploy VXLAN EVPN fabric on a Greenfield. In this lab, we'll import the clean fabric and configure VXLAN BGP EVPN in the site 1 using the NDFC. So the NDFC fabric controller clears all the configuration on the switches except the management before pushing the VXLAN EVPN configs on the switch. So it's the first day 0 step in the fabric controller's lifecycle management of my Greenfield fabric is to create the fabric where I define the fabric settings, such as the BGP, ASN, and we're gonna replication mode for the bomb traffic. So we're gonna build a bomb. Be a bomb that makes the broadcast, unknown, unicast, and multicast. And we're gonna define the underlay IGP protocol and a subnet schemes for underlay interfaces, and we have the BTAP interfaces and other settings. Okay, so we'll achieve this configuration of the fabric using a powerful and a customizable template-based framework. So with minimal user input, I can bring up the entire fabric with Cisco recommended best practice. There's best practice, okay, configuration in a short time period. So the set of parameters exposed to when creating a fabric in the fabric settings allows me to tailor the fabric to my preferred underlay provision options. So let's log on to the fabric next dashboard. Well, open NDFC. So we'll double click the Chrome, and here I'm gonna scroll down administration console. Then we'll find the app called Fabric Controller. Log on to it. So let's clear the welcome page by clicking Get Started. I'm going to go to Manage it, and we're going to click the Fabrics. We'll click the action is to create a fabric. Okay. First, the fabric name is going to be side. We're going to say side 1 Greenfield. We're going to choose the fabric, and we're going to select Datacenter VXLAN EVPN. In the general parameter here, BGP ASN, I'm going to make it 65111. That's we're going to give it a 65111. That's the AS number. And what we're going to find is underlay subnet IP mask. Underlay subnet IP mask will make 31. I will select the replication tabs. Right here, we're going to change the underlay RP loopback ID. We'll make it 251. So this step is going to create the loopback ID, loopback interface ID 251. It's used for the RP, and its IP address is going to be the RP roundable point for multicast. Let's go up, and we're going to select the advanced, and scroll down in the Greenfield cleanup options. I say Greenfield cleanup options. We're going to make sure it's enabled because we're creating a Greenfield site, okay? And go ahead, click the resources. We're gonna just scroll down until I see things called VF light deployment, and we're gonna pick is the back-to-back to external. So if we pick up the back-to-back to external is selected, VIF light the IFC, so I automatically create the between the borders devices of BGWs, the BGWs right here. And between the BGW in the fabric and the edge routers in the external fabric. So that we're going to take the IP address from the IVIF light subnet IP range pool. It's right here. So the next thing we're going to find is the auto deploy for peer. We're going to track this box. So when I select this option, the fabric controller can automatically configure to own the external device if it is the NX OS or AS9000 for the VRF Lite extension out of VXLAN EVPN fabric. So in this case, we're talking about the core router as a ISN node. Okay. Now on the bottom right here, click Save. Is to add switches. In the day zero life cycle for the Greenfield fabric, in the fabric controller is to discover and import the switches that make up the fabric. So the switch discovery and import process are done in either of the two ways. First, we bootstrap the new switches with the POAP or use the seed IP address of the switch in the fabric. So first, for the first option, a fabric controller has the fabric settings that I just finished populating, updating to the act as the power on auto provisioning server for bootstrapping. So this is disabled for this lab because the fabric switches resides in my virtual machine. So second option is what I used for the lab and is applicable for both Greenfield and Brownfield fabric. So in the closed fabric, each of the switch is an equal distance from each other. So a switch in my fabric is selected and the fabric controller lets me define and expected hop count to each to reach all other switches in my fabric for discovery. So this discovery happens by giving me access to the switch through the local admin user of a AAA user. So if you set up the fabric setting, this user must be able to SSH to the switch, perform SAMPV3 queries, and the show run commands. So one of the show commands is the CDP to discover subsequent directly connected switch. So not to exceed the specific hot count during the discovery. So I will perform the steps to discover and import switches in my Greenfield Site 1 fabric. So in the menu, I'll go manage and I'll double click the Site 1 Greenfield to open the fabric details. And in the fabric overview window, here is the action. I'm gonna add switches. Add a switch dialog. I'm gonna put the seed IP. We're gonna find the first switch and username. And we'll uncheck preserve configuration and we're gonna discover switches. Click confirm. Let's select all. and checkbox to select all 6 switches from the side 1, but I'm going to deselect the switch external router, and we're going to click add a switch. So when the import completes, we'll note the status change to switch added, and we're going to close this window. Alright, let's close the window. Now get the switches. First we're going to assign rows, and so we're going to click the side 1 BZW1 and give it action. We'll set a row. And make sure it's deployed as board gateway. Let's choose side 1 spine 1 and side 1 spine 2. I'll take an action and we'll set a row as a spine. Click OK for recalculation and deploy. So next we're going to do is to choose side 1 border leaf 1, and we're going to set a row as a border. So the side 1, leaf 1, and leaf 2 will remain as a leaf. We're going to next configure the access interface to the server. We'll click the interface. In the future, we'll type in interface equals Ethernet 1/5, which I'm taking care of the 2 interface under here to the servers. Okay. Let's pick side 1 leaf 1, side 1 leaf 2 for the Ethernet 1/5 port, and we're gonna give action edit. In edit here, we're gonna select policy. We'll make sure select int access host. Select. Let's click save and next. Alright, then side 1 leaf 2. One of these 2 of 2. Also gonna pick interface access host. Click save and click deploy. Let's click the expected config. Then when we're seeing this, then we're going to find what a configure put on the switch interface. And we go ahead, click deploy config. Let's close the window. Now you're seeing showing the interfaces in synchronize. Close that. So the last day 0 task I perform for my side 1 Greenfield fabric is to make my side 1 leaf 1 and side 1 leaf 2 VPC pair. So they're gonna become VPC pair. All in class array is a VPC domain. Okay, so for the switches tab, we're gonna do still double click switches tab. I'll create a VPC pair between switches by working with only one of the switch in the pair. So the fabric controller automatically detects the pair for me. So if it's not already open in the menu here, I'm gonna choose side one, leave one. Action here, VPC pairing. Now in the VPC pair pop-up, I'm gonna locate side one, leave two, and check this corresponding checkbox. And at the bottom right here, I'll click save. We'll pick is side one, leave two as pair, and side one, leave two shows as set to true, and it only recommends switch cable are being this pair because it connects to the side one, leave one right here. So at the top right, let's click action and we recalculate and deploy. Let's do some recalculating, config on the switches. So let's see in the deploy config, in the deploy config window here, so that we see the we have some pending config, and we'll click deploy all. Now all nodes to deploy, so let's close the tab. So next step, we're going to create the VF. Is an overlay or tenant in VXLAN EPN needs a layer 3 L3 VNI for system metric IRB if I need inter VXLAN routing. So an L3 VNI is associated with the tenant to VIF routing instance that separates the routing domain between tenants overlays. So this is one of the powerful things about the Fabric controller. So it automates and provides the health check that all VIF, BGP, EVPN, and VXLAN configuration is correct. So this can be one of the configuration to handle in a large production environment with many peers and many tenant overlays. In this section, I will create and stage the first tenant overlay VIF and associated L3 VNI. In this lab, I go through the workflow to create networks that includes layer 2 L2 VNI and VLANs, and associate them to an overlay tenant to VIF. So in the Fabric overview, we have the side 1 Greenfield. Let's click find VIFs, take action to create. First VIF name we're gonna create is called blue VIF, and VIF ID is 50,000. That it comes from the pool of VNIs I created while creating the Fabric. VLAN ID, I just proposed VLAN 2000. That post VLAN from the VLAN pool I created while creating the Fabric and places it in the VLAN ID field. Templates will keep as default VIF universal. Default VIF extension universal for the extension template. VIF's VLAN name, we can define VIF, blue VIF, copy all that, blue VIF descriptions, and we'll click create. I'll creating a VIF. Next we'll create networks. So networks in the Fabric controllers that are where I define layer 2 VNIs associated to the VLANs for the layer 2 segments, and I will bridge domains over the routed Fabric. So L2 VNIs enforce segmentation by not allowing layer 2 traffic to traverse the VNI boundary. if I need inter-VNI or VXLAN routing, the L3 VNI VRF is required. So if you need is that switch to the virtual interface SVI or VLAN interface, we'll call it the anycast gateway existing on all leaves that I configure and associate to L3 VNI VRF. So if I do not need the route between the L2 VNIs, then L2 VNI can be layer 2 only. So this lab I defined two networks for inter-VXLAN routing that I associate to L3 VRF I created in previous steps. So on the top here, we'll click networks. Action we're gonna to create a network. We'll call it blue net 1. That's my L2 VNI name. And uncheck this layer 2 only because we wanted to route to the L3 VNI. So I check this if we're creating L2 only network. Okay, so VRF name is automatically populated via blue VRF. Network ID is 30,000. We're gonna propose a VLAN. So we'll keep templates at the default. So IPv4 gateway net mask, we're gonna give it 11.124. VLAN name, I'll say blue net 1. The description is same. Okay, that's my BlueNet 1 network. Click create. We're gonna to create a next network. We'll say BlueNet 2. Okay, uncheck layer 2 only. Network ID automatic populated. We'll propose a VLAN. So we're gonna to say network gateway and a mask. VLAN ID BlueNet 2. That's my interface name. So click create. So this is what the networks look like when I finish. Okay. So next, let's create the attachment. In the fabric control, VRF network attachment can happen independently. I can create VRFs and attach them to leaf switches and create networks, and attach them to leaf switches. I can combine the network flow where I create a VRF, then associate networks to VRF, and finally deploy the networks to which deploy VRF. All this adhering to Cisco best practice. I have staged my overlay tenant VRF and staged two hosted networks that are associated to my overlay tenant VRF in previous lab. That is now time to create these constructs to leave switches and their required. This requirement comes based on the design how hosts such as EXSI connect to my leaf switches. These are two standalone Linux instances that are connected to my Sci 1 leaf 1 and Sci 1 leaf 2. Switches to only Ethernet 1/5. This is the interface that I used a policy to configure as an access interface, leaving the access to VLAN undefined, and other parts of the attachment workflow is selecting interfaces for network that are deployed, whether it is an access or trunk interface. So for this lab, I will select Ethernet 1/5 interface between my two leaf switches for each network I previously created. In the network, I will double click blue net 1 and then click network attachment while selecting the checkbox next to side 1 leaf 1 switch. Click action and add edit. In the Edit Network Attachment screen, we'll click the slider to attach, then click checkbox next to Ethernet 1/5 in the side 1 leaf 1 switch. At the bottom, click Save. Let's close the attachment tab. Attach the second network to side 1 leaf 1, side 1 leaf 2 Ethernet 1/5 in the side 1 leaf 2 switch. Okay. Click Edit. Let's go to it. Double click. Now attach. Find the side 1 leaf 2. Attach this interface 1/5. Click Save. Now we have two pending configs. Now let I attach networks, and they are pending deployments in the Nexus-Fabric controller. It is time to deploy. On the top right corner, click Recalculate and Deploy. Now side 1 leaf 1, side 1 leaf 2 are showing out of sync. Let's review the pending configuration and then click Deploy All. When complete, let's close the window. To see the network deployed, click Networks. I'm seeing bootnet 1 and bootnet 2 are configured. When performing the action to deploy the network attachment, intent is for my VIF to deploy at the same time because the VIF association with the network when I create it. So let's confirm the VIF are also deployed. Let's verify side 1 fabric. Through the Nexus dashboard fabric controller, I have created and deployed my side 1 Greenfield VXLAN EVPN fabric and performed a level of verification by checking deployment status that NDFC reports. Now, I'm going to connect it to some devices in my side 1 fabric to issue show commands that should verify the configuration. Nexus dashboard controller deploys also using the Linux server that are connected to my side 1 leaf 1 and side 1 leaf 2. I perform data panels verification by checking connectivity to my Anycast gateway and checking inter VXLAN routing between my two servers. So let's open the session. First, I'm going to verify side 1, spine 1. So show IP OSPF neighbor. Well, I'm seeing the neighbors are fully up. Let's show BGP, L2 VPN, EVPN summary. It is to verify side 1, spine 1 BGP EVPN neighbors. Verify side 1, leave 1. To open connection to leave 1, then we're going to show VPC. And to show VXLAN VNI, show NVE VNI. I can see my bootnet 1, bootnet 2, and boot VF as L3 VNI. Let's verify side 1 data panel. So there are 2 Linux servers that are connected to my side 1 leave 1 Ethernet 1/5 and leave side 1 leave 2 Ethernet E/5. They are both connected E15. There are 2 servers. So my job is to use testing inter VXLAN data panel connectivity within the same tenant to overlay VF in my side 1 fabric. So by pinging the server 1 to server 2. So let's log on to server 1 and server 2. In server 1, I'm going to ping server 2 IP. Okay. That returns to the side 1 Greenfield view. I can see the ping is okay from the other side. Yes, I verified the IP. The ping from side 1 leave 1 and to side 1 leave 2 from server 1 and server 2 are pingable. Let's go back to NDFC. Let's close the view. I'm going to go to the overview and the topology. In the menu, let's check the topology. I'm going to double click the side 1 Greenfield. And we'll change the view mode to configuration. When all switches are green, they are synchronized, and I can hover over a link or switch to view some more details.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget